Good morning, everyone. Welcome to this first webinar of the TerraDT project, co-organized with UrbanAIR and WeatherGenerator projects. So these three EU-funded initiatives started earlier this year in January. And as you see from this slide and the title of the webinar, we're all working towards expanding the Destination Earth initiative with various applications connected to the Earth system. While we wait for more people to enter, let me just remind you that this webinar will be recorded and it will last an hour and a half. My name is Maria Giuffrida. I am from Trust IT, an Italian SME, and I am the leader of the communication and dissemination activities for TerraDT. Together with me today, there will be many other speakers, representatives from the three projects. Also, we will have a representative from the European Commission, which we're very happy about. We will go through the main, let's say, activities and objectives of the three projects. So, but before introducing the agenda and, everything that will be discussed during this 90 minutes event, let's just have a look at who is here with us. So a look at the audience side. These are the statistics of the registrations that we had until yesterday. So assume as of now, they might have been a little bit more. Of course, these are the registrants. The actual participants might be less live because, maybe some people cannot attend. But as I said, this is recorded, so it's not a problem. The majority of the registrants are coming from the research and academia environment. Then we also have business and industry representatives, some citizen scientists, and also some policymakers. We've had registrations from around 25 countries, but I was too long to put on a slide. So I will ask you a first question. This gives me the opportunity to introduce a tool that we will use also to animate a little bit the discussion later on. The tool is Slido. Maybe some of you are familiar with it. So just a very quick ice-breaking question for all of you. In case you can connect to slido.com and enter the code that you see here, 8687874, or scan the QR code if you want to use the cell phone. Insert the country. So I see the first replies already coming through. We have many people, most people, I think, from Germany, but also Spain, Italy, Netherlands, Finland, also Morocco. So yeah, mostly European, but also outside of Europe, Turkey. And I guess this chart will fill with more countries and more names as the number of participants I see is still progressing, even from India. So very global and international audience today. So keep in mind this tool because we will use it also later on. And also feel free to use the chat that you see on the right side of the screen if you want to share more. Okay, so if you want to tell us more of who you are, why you are here, and what's your research topic, what you're interested in, feel free to do that. Let's try to use this webinar also as a short networking opportunity, even if it's not that easy, being this an online event. Okay, so let's have a look now at the agenda. We will start with an introduction by Marco Adamovic from European Commission, DG Connect. Marco will present the Destination Earth initiative to us. And then we will have the presentations from the three projects that are organizing this event. So we will have Jenny Kontkanen from CAC, coordinator of TerraDT. Then we will have Martin van Ruwijk from Imperial College London representing UrbanAIR, and Peter Duben from ECMWF representing WeatherGenerator. Then we will have a short break with an interactive session moderated by my colleague Roberta Fabrizi from Trust IT. And then a final panel discussion moderated again by Jenny, where we will have Nikolai Koldunov as a representative of TerraDT, and again, Peter and Martin for WeatherGenerator and UrbanAIR. We will have also a Q&A session allocated at the end, but please consider that we want to make this event as interactive as possible. So feel free to ask your questions whenever you want using the Q&A box that you see in the toolbar of Zoom. Okay, so this is my final slide, just a reminder of the housekeeping. The event is recorded, as I already said, and the recording will be available on our website and YouTube channel after the event, together with all the presentations. Feel free to use the Q&A box whenever you want, and we will try to address questions as we see them, both during the panel or by writing the replies, and also use the chat for anything else that you want to share, and also to go on the links that we will share regarding additional materials from the 3 projects. So I hope you enjoyed the webinar. Welcome again. And now I leave the floor to Marco for the first presentation.
Hello, good morning, everyone. I hope that you are seeing my slides. I will just try to, voila. Do you see them?
Yes, we can see it. Thanks.
Good. So thank you very much for, first of all, for the invitation to this, the first webinar, hopefully in a row of many upcoming, in the upcoming years. So my name is Marko Damovic. I'm a project policy officer of Destination Earth Initiative at DG Connect. So we are, I'm part of the C1 unit, so we are dealing with high performance computing applications and initiative, and one of the initiative is Destination Earth. I will give a short presentation of 10 minutes, so mainly focusing on the main achievements that we have achieved so far up to today, and also what are the upcoming activities where you, Horizon Europe projects, but also any other stakeholders, mainly based in Europe, can still contribute to it. So as you know, one of the main objectives of Destination Earth is really to provide a highly accurate digital twin of the Earth. It has a multiple objectives. So one of the objectives, the main objectives, I could say, is really to monitor, simulate, predict natural phenomena. So due to the climate change, we all are aware of the high implications of different impact sectors that we are experiencing and facing in an everyday on an everyday basis. And Destination Earth is here really to try to assist in the designing accurate adaptation strategy on one side, but also to help with certain mitigation measures. How do we do that? We do that by leveraging existing and new data sources, but also EU advanced digital computing infrastructures. Destination Earth, as mentioned, it's a European flagship initiative. So it is also, the objective is to accelerate the EU green, but also digital transition. What are distinguishing Destination Earth? This is also something where you, Horizon Europe projects, will contribute. It is also to be able to create and test so-called what-if scenarios. So it's really to try to link the weather and climate simulations that I will show shortly, that you also might already be familiar with the impact sectors. So it's really the Destination Earth is really trying to contribute as much as possible to the downstream applications. So it's really to support the decision making, not only the EU or national level, but also on local and regional scale. Therefore, in order to be able to support these stakeholders and policymakers, all these complex simulations that I'm quite convinced that you are doing in your each one of the projects, these complex simulation systems should be somehow accessible to also a large range of user applications. That's why we have Destination Earth platform that I will also briefly introduce later, where the end users, what they are really interested is really to have some nicely graphical user interfaces, self-explained with nice tutorials and guidelines that could really guide them and tailor to their everyday decision making in order to be able to derive some informed decisions at the end of the day. The last objective of the Destination Earth, this is something that we are highly working on also with you in Horizon Europe project, but also with our 3 entrusted entities, is to really try to leverage as much as possible the existing AI models, but also to test how these models can be scaled up and overall to boost the exploitation of AI tools and applications. Destination Earth in a nutshell, so it's a $500 million project. It started 2021. 2022, as you all aware of, so every year we have different calls that are linked to digital twins of the Earth. You have been selected in the previous one, and we are really looking forward to see how you can also tailor the evolution of the destination Earth in the future. We have a significant involvement of the EU industry, so a lot of countries are represented, private industry, organizations, SMEs. As already mentioned, it's led by us. It is implemented by three trusted entities, so ECMWF, ESA, and EUMETSAT. Currently, as I mentioned, we kicked off in 2022. We are now currently in phase 2 that runs until June next year, where we are really also looking forward to see what is coming out from new projects, and that we can also see together later on how we can implement and make interoperable your solutions and services with Destination Earth. So this is where it comes to the integration of additional digital twins, and also for the development of application services is something that will also go not only in phase 2, but also by the end of phase 3, that is by 28. The idea is really to make Destination Earth platform operational by 2030. That means that we will have the completion of a digital twin of the Earth system, and also for operationalization of the system. I will not go through into much details, but you might, I would also, well, I kindly invite you also for those that still didn't have a chance to visit our DestinE platform. You will see that we have different type of use cases. So this kind of a use case is pilot services that were focusing on different thematic fields such as flood risks, energy, air quality, forestry, and so on. So these are the applications that you already have access to. So you can, if you are registered as a user, you can access them and then play a bit around to see what is the added value, then see how, if relevant, of course, you can incorporate in your project and research. So the Destination Earth has three main parts. The first part is that is developed by ESA, European Space Agency, is the DestinE Core Service Platform. So this is the, let's say, the landing page when you go to the destineplatform.eu. It allows access to infrastructure services. It also allows the access of various huge amount of data that are coming for different fields. It also allows you, thanks to the new services, to create your own new workflows to promote the services that you might be interested, that you have developed, you might be interested to share it with the broader community. It also allows to stream a collaboration. So it has also the sandbox, so you can even have your own type of a small cluster where you can then test with your own, let's say, team members, certain tools and services before you actually make the environment live and open to broader audience. The second, let's say, pillar of Destination Earth is this DestinE Data Lake that is implemented by EUMETSAT. And here you can see that we also have a different type of services and spaces. So mainly data lake, as name itself says. So it really gives opportunity to gather and to store a federated data set. So for the moment, thanks to the data lake, we are able to make connections with Copernicus services, for example, Eurosat data, contributing missions from the three implementing entities, but also from the GRC, for example, from the DG Joint Research Center. So we also have data that are coming from Global Human Settlement Layer, 3D City Mesh, and so on. What is also interesting is, as we can see also on the picture, is that thanks to the data lake, we are also able to actually retrieve the huge amount of data that are produced by digital twins, actually, the extreme digital twin and the climate change digital twin. So to go into more details, so the extreme DT and the climate change adaptation digital twin are the twins that are developed by ECMWF. And they are great, they are high resolution data sets produced thanks to these twins. And regarding the extreme digital twins, what we are having for the moment, it's really the global daily simulation of extreme weather, around 4 days at the 4.5 kilometers. What it also enables us, that is something that is really maybe one of the unique features currently Destination Earth, that is also triggering the on-demand regional simulation. So once the certain anomalies, the high precipitation events, for example, have been detected, then we are also able to zoom in kind of in a certain time and special window up to 2 days, and the 7th of and at the resolution of 500 to 750 meters. This is important because this is actually the tools that regional authorities are needed in order to really derive the informed decisions in different impact sectors. The second digital twin is on a climate change adaptation digital twin. So it allows really to go into high resolution. So on the bottom left side, you can see that what we achieve in Destination Earth is really to go from the IPCC, for example, 100 kilometers resolution to the 5-kilometer resolution. And this is important because thanks to these digital twins for the moment, we can really try to answer certain questions that are really linked to the relevant for the policymakers and stakeholders, such as, for example, if there is an approaching storm, for example, at the North Sea in Europe, so the certain companies, renewable energy companies, could really try to integrate this in their everyday business and to see how this storm will actually affect their energy production. Or for the urban planners, for example, they could also see and test to see how the heat waves, for example, would eventually look in 2 or 4 degrees changing climate, and to see what type of adaptation mitigation strategy they would need to apply in order to be better prepared for such changes. What is also interesting with digital twin, ClimateDT, is that also today we are also able to produce so-called storylines of extreme events. So, for example, we are also able to take, for example, the Paris heat wave 2019 and to see how this heat wave would have actually looked like in the 1950 conditions, or, for example, how this heat wave would look in 2049, for example, 2 degrees warming. As already mentioned, we are currently in a phase 2. So the phase 2 is really focusing on the development of additional product feature. So the artificial intelligence and ML, of course, are in the core activities of our system. And this is also where many of you will also contribute directly or indirectly. Uncertainty quantification and synergies with Horizon Europe projects, so from the Pillar 1, but also from the other projects from the mission adaptation, for example, is also something that will be harvested as much as possible in phase 2. User engagement outreach activities is something that we are doing on the ongoing basis. So we are really trying to assess and to address different levels, as mentioned before, not only EU, but also national, regional, and local, to produce and to enable certain service application really that are tailored to their needs. No, so to answer the questions and the doubts they might have regarding to different impact sectors. This is the platform that I would, as mentioned before, would really like you to kindly to invite to visit. So platform DestinE.eu, where we can have a lot of services. If you don't already have the access, so I would already ask you, I invite you to register. So you have 2 different types of access: the basic access and the upgraded access. So upgraded access is really for the institutions from the European institutions, but also from the research and academia, SMEs, industry, that are interested in the leveraging the access and digital twin simulations and data. And currently, actually, soon we have already also expanded the user case and the user that actually use our services. This is something that will be published soon. So keep update for the positive news regarding the access. Finally, as mentioned, destination and really the in phase 2, but especially also in phase 3, we are really trying to go towards the AI Earth system model. So really to try to integrate different components of land, ocean, sea, ice, wave, leverage AI tools, high performance computing system in Europe in order really to bring the added value and derived informed decision for decision making at the downstream. So in the impact sectors, that could be energy, that could be flooding, that could be wildfires, departments, and so on. Some tools that we are currently in a pipeline to be developed. I will not go through it for the sake of the time, but I think it would be nice to mention is the AI climate simulator. So here we will try to explore what if scenarios in a changing climate in order to really test the uncertainty and quantifications. When it comes to the uncertainty, we are also developing the European Machine Learning Foundation model in order really to be able to set up voila, certain workflows for various applications across different type of data. What is also interesting is that we are also trying to develop for AI forecast in a box. So this is mainly will be developed maybe not only for the European, but also wider. It's really to give possibility for a certain interesting parties that doesn't have a lot of, let's say, computational capacities and capabilities. So they would be able to eventually run the forecast and, in a box on a certain time and spatial scale. LLM and chatbots, this is also quite a fashion nowadays. This is also something that we will develop, really to try to guide users throughout the usage of different tool service applications that we are having on DestinE. So one might imagine that it's coming from the research, for example, from a flooding, and he might just, pop up, throw certain questions in a chat box, and then the LLM will give actually all the steps that he or she needs to follow in order to fulfill his user needs. Voila, so thank you very much. Voila, I'm here for any questions you might have. Unfortunately, I will not be able to remain until the end of the webinar, but please, voila, do not hesitate to contact me either directly or indirectly via the project coordinators. So thank you.
Thank you very much, Marco, for your introduction. Actually, we've had a question for you in the Q&A box. I don't know if you can read it.
Yes.
It was actually sent before you showed the slide on AI and ML, so kind of anticipating what you just presented. But I'm not sure if you want to say something more, or if the person who asked the question, I don't see the name because it is anonymous, but if the person who asked the question, basically if your question was answered by Marco's latest slide, or if you have additional needs, maybe you can also clarify better. So I'm speaking to this anonymous if they reply, but also in general to you, Marco, if you want to add anything, you can do it now, or you can also type in the Q&A while we go on with the event, as you wish.
I'm just trying to find the question. Can you maybe repeat the
Yes, so the
for
question
me?
is, with respect to climate science and AI ML implementation, how we can become involved and contribute.
So as mentioned, so we are really open for as relevant contribution as possible within the destination Earth. So we have also different calls. So as mentioned, so we have three entrusted entities. So the ECM, ECMWF, ESA, and EUMETSAT. So from time to time, we will have. They are also, let's say, give certain call for proposals to develop certain machine learning demonstrators for the moment. So when it comes to that, so currently the call is still open, if I'm not mistaken, by next week. So if you go to the Destination Earth platform on the ECMWF side, so where you have the explanation of digital twins, there, for example, you can see ongoing procurement calls where you can directly apply and contribute. Of course, there is a selection procedure similar to what you have experienced throughout the Horizon Europe projects. But there is ongoing, let's say, every 1 or 2 years, or certain procurements or call for proposals are published by three entrusted entities, where we receive the contributions depending on the priorities, of course, of the commissions that have been set. Voila, this is something ongoing. And I invite everyone to contribute directly, but also if you have a service, for example, that you already would like maybe to publish it on the Destination Earth platform, that is also something that is possible, and that's something that you could also see. There is an onboarding section on the DestinE platform where you can see all the guidelines, how and steps that you need to follow in order to request the onboarding or your services on the DestinE. Of course, it must have the added value. And then once it is approved from our side, then it is visible to the community. Well, I hope this answers your question.
Thank you very much, Marco. So yeah, we'll see if other questions come later on. Now I pass the floor to the coordinator of TerraDT, so Jenny. The floor is yours.
Thank you. I will share my slides. Okay, I think you should be able to see them now.
Yes.
Okay, excellent. So I will then start. So thanks a lot, Maria, for the introduction. So I'm Jenni Kontkanen from CSC IT Center for Science, and I will introduce the TerraDT project. So I will start with a brief background. So like we already heard from Marco's very nice presentation, Destination Earth is a European Commission's initiative that develops digital twins of Earth with the goal of supporting decision-making on topics such as climate change. However, there are some limitations regarding how well Destination Earth can support climate adaptation efforts. And these limitations include, for example, that the kilometer scale climate models of Destination Earth have still some shortcomings for some key components of Earth system that include, for example, cryosphere and land surface. Additionally, adding new components to these models is challenging as the models currently are not built in a modular manner. And in TerraDT project, we aim to respond to these needs by developing new digital twin components, impact models, and also a modular software infrastructure that can enhance Destination Earth infrastructure with the goal of enabling Destination Earth to provide more reliable and relevant information for climate adaptation and mitigation. So TerraDT project started in the beginning of this year and will last for 4 years. The consortium includes 18 partners and represent 10 countries, so Finland, Czechia, Estonia, Germany, Italy, Norway, Portugal, Spain, Sweden, and Switzerland. We at CSC IT Center for Science coordinate the project, and you can find the TerraDT website behind that QR code. Here you can see the TerraDT partners in more detail. I don't go them all through here, but I will just mention that the partner organizations represent different expertise ranging from climate research to high performance computing, as well as to evaluating climate change impacts on different topics. And of course, we have also their communication partners, like Trust IT, who is organizing this event. I will next go through the TerraDT project's objectives and also concrete outcomes that are linked to these objectives. So the first objective is to build and deploy this new digital twin that we call TerraDT to provide improved climate protections and impact assessments to support decision making. So the concrete outcomes of the TerraDT project linked to this is that we develop digital twin components for land ice, sea ice, land surface, and aerosols, and each of them will be coupled to core climate models that are the same models that are in the heart of the Destination Earth climate adaptation digital twin. Other outcomes include development of impact models linked to land ice, sea ice, forest, and urban areas, and these impact models provide this kind of user-relevant information on these different topics. We also perform multi-decadal coupled simulations with these new components. This schematic here illustrates these components a bit more. So here on the left-hand side, you can see these core climate models. They are ICON, IFS NEMO, and IFS FESOM. And as already mentioned, they are the same models as in the Destination Earth. They are all global kilometer scale coupled climate models. Then in the middle, you can see the digital twin components. I already mentioned the topics on which we develop them, but they are related to themes of cryosphere, land surface, and aerosols. Then we have these impact models, or we develop also these impact models, and they take in the outputs of the core climate models and digital twin components to provide this kind of user-relevant information. So the topics on which the impact models will provide this information include sea level rise, glacier retreats, shipping, offshore and coastal construction, as well as forestry, carbon sequestration and biodiversity in the forest, and also urban planning for climate extremes and urban carbon sequestration. Then the second objective of TerraDT is develop a modular, scalable, and interoperable infrastructure that can enhance the destination Earth infrastructure for software, high-performance computing, and data handling. The concrete outcomes related to this is that we will develop a generic coupling interface that will enable adding new components to these core climate models in a more flexible manner than currently. We will also improve performance of these coupled models, as well as develop data governance and workflow solutions that will be compatible with Destination Earth. Then we also develop applications for the impact models that will be deployed to this Destination Earth platform that we already heard about in Marco's presentation. And 2 of them will have interactive user interfaces that will enable users to explore and address these what-if questions. And the TerraDT system will be deployed to 2 EuroHPC computing systems. So Lumi, that is located in Kajaani in Finland, and Marenosm 5 that is located in Barcelona in Spain. And these same systems are also utilized in Destination Earth. So this figure here illustrates how TerraDT builds on Destination Earth climate DT approach, while adds their new technical and scientific capabilities. So here you can see with the blue boxes, this climate DT approach, and then the TerraDT adds these new elements there, which are shown with yellow boxes. So these now include this generic coupling interface, enabling coupling the new components to the core climate models. Then, of course, these new digital twin components, as well as these impact models. Then the third objective of TerraDT is to ensure that TerraDT is taken up by scientific community and users from public and private sectors through different engagement activities. So the concrete outcomes related to this is that we will organize impact and policy workshops to interact with users and stakeholders. We will also produce outreach material, publications, and conference presentations. We will, together with the users, develop user stories as well as an adoption toolkit that will ease the take-up of the TerraDT developments by the users. We also aim to ensure that our work is strategically aligned with Destination Earth and other key initiatives. And we also want to contribute to international collaboration efforts related to Earth system digital twins. And as a final concluding remark, I want to say that in TerraDT, we develop new digital twin components, impact models, and modular software infrastructure to enhance the capabilities of Destination Earth. And you can see in this figure here different topics and processes that we are working on in TerraDT. So thank you. This was my short introduction to TerraDT project.
Thank you very much, Jenny. We will see you later also for the panel. Now let's go to the other presenters. So we have Marten van Leeuwik for UrbanAIR.
We can see your screen, but we cannot hear you, Martin.
Ah, yes, apologies. I've unmuted myself. So hopefully you'll be able to hear me.
Yes.
Yes.
Great. Hi, everyone. I'm Marten van Leeuwik. I'm a professor of urban fluid mechanics at Imperial College. And I'm here kind of presenting our project UrbanAIR, which is a new digital twin to support climate adaptation in cities. So we're focused on the city primarily. So we consist of a large number of partners, 18 to be precise. So the project is led by TU Delft, by Femke Vossenpoel, who could not make it today. So I'm speaking in her place. Yeah, so there's universities involved, there's design consultants involved, people representing cities, and computer science experts, etc. So it's a very interdisciplinary group we have. So what does UrbanAIR stand for? It is, hold on, I lost my screen. It stands for Urban Simulation for Air Quality and Heat Resilience Strategies. So we're really focusing on the micro scale. Cities, what can they do to become more resilient? So climate adaptation, how can we help them make science-based decision for urban planning and design? So you might think here about wind comfort, but also, how do you deal with recreational spaces, greening, choices for mobility, etc. And also hazard response, right? So climate change will cause more extreme events. So how do you prepare for wind extremes, heat extremes, air quality extremes, etc. So I've already mentioned this, but it's an interdisciplinary group, urban scientists, environmental modelers, engineering consultants, etc. And together we've got a large range of tools available, and the idea here really is to combine a lot of these tools together and connect them to the destination Earth infrastructure. So key to designing a successful digital twin is to actually talk to them and to engage with them closely. So in this project, we've partnered with 5 cities. 2 of them we call action cities, which is where we have kind of established collaborations, and our partners are already kind of engaged in developing digital twins to some extent. So these are Barcelona and Antwerp. And then we have 3 learning cities where we will apply these digital twins and test them in different settings. So these are Paris, Rotterdam, and Bristol. So as I said, it's really crucial to kind of listen to what the planners need on a day-to-day basis, which is often different from what we as scientists think they need. So what is the dilemma? We sit with them and we kind of listen to their needs, and then of course based on what we can actually do, because in general decision makers think about a lot more than we tend to think about. We come up with something that we do. And one of the interesting things, for example, here is that if you speak to Barcelona, they're kind of more interested in air quality like digital twins, whereas the city of Antwerp is more interested in heat resilience. So within UrbanAIR, we've got a large number of tools available. So we've got physical models. So these are regional and mesoscale models. So we already saw a little bit about these. So these are, for example, the mesoscale models that branch off from the extremes digital twin and provide these high resolution forecasts at 200 to 500 meter resolution. But then we will downscale further, because a lot of the climate and so on and air quality problems are really local. So they require, well, meter scale kind of resolutions. So we've got city scale large eddy simulation tools, which will operate at about, say, 20 to 100 meters. Street scale large eddy simulation and Reynolds average Navier-Stokes models, which create predictions at around 1 meter resolution. And then also some more kind of operational models. So these are models that simplify the flow, but capture a lot of the relevant processes otherwise. So urban climate models, which you can operate at a city scale and also at a speed much greater than some of these quite computationally heavy and demanding tools, and air quality models. Then it's really important to also kind of engage and to gauge what the population does. So we've got people working on behavioral models in the team. So these are both kind of short-term behavioral models. So how do people respond to extreme events, as well as long-term behavioral models. And we have decision support tools available. And then, of course, it's very important to also quantify the uncertainties associated with any predictions or estimates. So that forms an important part of the project. And in this category, we also put emulators, right? So how do we kind of make our predictions fast enough? And we look at data fusion and super resolution, as well as data assimilation. So here is an example of our downscaling strategy. I already kind of mentioned it in words earlier. So here we've got the two digital twins that form part of Destination Earth on the right-hand side. From that, we output the extreme event. We can zoom in, so we zoom into a certain region at resolution, say, of 200 to 500 meters, and then we will cascade down again and go down to kind of order meter scale resolution to really kind of work out what happens at the neighborhood scale. And of course, it's really early in the project, so we haven't actually got a working prototype, but we are working on putting all the bits together. So what I'll do in the remainder of this talk is to kind of take you through a user journey which we've identified together with the city of Antwerp. And as I already mentioned, they are really interested in how can we make our city more resilient, and they're very interested in green infrastructure. Yes, okay, where can we plant trees? How do we optimally use parks, etc.? So this is what we're planning to do. So as first we sit down with the stakeholders, formulate the problem, identify the criteria that they see as important for making any decisions. Then we'll run scenarios. So we use the Extremes digital twins for this. So this is some work that's done by Ulf André from SMHI. So here we extract a heat wave in the Netherlands, or for Antwerp really, which is here, which is what we're focusing on, obviously. So we run this high resolution regional model. Then we scale down again. Yeah, so this is kind of the mesoscale model. We zoom in on a region around Antwerp. Then we get here on the left-hand side, we get predictions where you can see, for example, the River Scheldt really clearly from being cooler, etc. So we're now at resolutions of, say, order 100 meters. And then in the final step, we zoom in again, right? And here we zoom in right up to the kind of neighborhood scale level in this blue box. And we run simulations at street level. So these are simulations done with Palm, and they were done by Nushin Nauzeme from the University of Hanover. And you see here, this is the wind velocity on the left-hand side. You see temperatures, you see them changing because we're simulating full diurnal cycles. That's really important because the urban fabric stores heat during the day and releases it during the night. And at this level, materiality becomes really important, right? Do you have locally trees around? Do you have water in the area? How high are your buildings? What is the material of the buildings? So all these things are important to make microscale predictions, right? So once we got that, we put on top a layer of behavioral models. So how do people respond to this heat wave event, and what is their actions? Because in the end, we're interested in the people, obviously, because it's the people that are exposed to the heat. So we need to know what their heat stress is. Uncertainty quantification. So we need to kind of how convinced are we, or how confident are we in our predictions? Where are the biggest uncertainties? And then finally, decision analysis, again, together with the stakeholder. So interactivity is obviously really important. These algorithms, they only capture a fraction of the important decisions that urban planners need to make, right? So we will never capture all the criteria. So this decision matrix is done together with the stakeholders, after which they can make a decision of where they should place their new infrastructure, or how they should modify the city to make it more heat resilient. All right, this is all that I have for now. As you can see, there's a lot of work to be done, but we're very excited to be part of this Destination Earth initiative. So thank you.
Thank you very much, Martin. We actually have a question for you in the chat, and I would like to ask you to read it and maybe type the question so that we can go on with the webinar without delaying. And also there is a question for Jenny in the Q&A that I think she's addressing already. So thank you again. And Peter, now the floor is yours.
Thank you very much. I'll just share my screen. I've done that, so you should see me now and the screen now, and hear me as well. Perfect. Yes, I'm going to talk about the WeatherGenerator, the third of the 3 sister projects. Basically, short motivation. I think that's kind of obvious to a lot of us in this webinar here, but in principle, we have seen that with climate change, we have basically had a change of the frequencies of extreme events, and basically we need to, as Europe, obviously be prepared for these kind of extreme weather events and a changing climate as well. And machine learning can help here. So machine learning can play a role. A lot of you have probably seen that machine learning had a very strong impact on weather predictions already. So just to give you one slide here, there's a figure on the right where you see the forecast quality of the forecast we had at DestinE over time. So it's kind of the x-axis is time in years and decades. And you see that this kind of slowing going up over time. And that's what we know as a quiet revolution of weather forecasts in principle. And now you see basically that there's a step change here with new models coming in that basically are like a delta step basically better than the old model. So the different colors are different forecast lead times, and now suddenly there's a step happening. And this step is actually happening because we have machine learning models now in the mix that are basically providing much better quality in the forecast scores across the different lead times. So the quiet revolution that we had over the last couple of decades, that machine learning models, the physical models were developed, the physical models were developing over time and improving weather forecasts, is kind of dead at the moment and replaced by the machine learning revolution. And also, if we kind of compare the quality of machine learning models, like for example, AIFS, which is the operational weather forecast model that just went operational for the ensemble last week at DestinE, they are kind of years ahead in terms of forecast scores for deterministic and ensemble predictions when compared to the physical models. So there's a lot happening here. And also these machine learning models we turned out to be very trustworthy as well. So it's not just kind of a bit of an interpolator that is just pleasing the scores, but actually a good forecast model in principle. So a lot is happening on the numerical weather prediction side. We see also a lot of studies in the climate side, but we still have kind of to explore a little bit more what this actually means here. So the question is now what's coming next. So we have had a huge speed of developments in machine learning over the last couple of years. And the question is like, what are the next developments that are happening? And typically in the last couple of years, we followed a little bit the trend of other domains regarding the architectures that we, for example, looked into with machine learning and the training procedures and so on and so forth. And the one step that we haven't really done in our domain is the step towards what we call a foundation model. And foundation model is a buzzword. So there are a lot of different definitions around, and I'm basically trying to define what a foundation model is with this slide here. So let's go to the area of languages, language modeling with machine learning. It started basically with so-called task-specific tools where you had a specific task to fulfill. So for example, you wanted to learn a mapping between English and Spanish. And once you've learned this with kind of using English text as input and Spanish text as output, you basically had a language translation tool. Good. But at some point, people realized that kind of they built so-called large language models that were slightly different because they basically used not just a specific application and specific task, but they actually used like all text that was available on the internet, like a huge amount of text, And then they kind of produced gaps in the text and they filled them with machine learning in a so-called self-supervised training procedure, which is slightly different to the task-specific training. And then they found out that they actually kind of were building tools that were much more generic. So suddenly, with tools like ChatGPT, you can basically ask the same tool to kind of give you a recipe for vegan lasagna in Spanish, and it will do that. Or you can ask it to kind of just translate between English and Chinese. It can do this for all the different languages. You can also write a Tudor-style language, as Shakespeare would have written an invitation to your birthday party, for example. And these tools are very generic and can kind of come up with a lot of different, well, it can be used in very different ways. These tools are very massive as well, so they're much larger than the task-specific tools in principle in terms of the machine learning solution. But you can also fine-tune them and distill them out to kind of make them small again into this range of a tool that is kind of still handy to apply, basically, in the end. And the question is now, will weather and climate also make the same step? So will we also have very similar models and tools in the future in the weather and climate domain? And this is kind of what we're exploring with the weather generator. So what we want to do is we want to build a machine learning tool, like a very large machine learning tool that is probabilistic as well. And we want to kind of build it or design it in a way that it can kind of get all sorts of different inputs, whether it's reanalysis data or simulation data or observation. You basically give it whatever you have in terms of the input. And then you generate a lot of different, a large variety of different output fields as well. Some of them can even be user specific, for example, energy output or something like this. And the ambition is that this tool should be able to cope with all sorts of data, whether it's global or local, whether it's 100-meter resolution or 100-kilometer, whether it's in the past, present, or future. It should be able normally to generate you kind of the different data sets and the output, whatever you give it as an input, basically. And this can even be just a date, for example, or just like something like in the sea surface temperature field or something like this. So you can also be very generative in your solutions, basically. And the second part, so that's the first step that we want to do. We want to basically have a lot of different input data sets. And the second part is that we also want to have this self-supervision kind of idea. So here again, it's a plot with a lot of different data sets on the y-axis. There's also like a space dimension on the y-axis. It's a sketch, obviously, but there's kind of different spatial dimensions as well. And there's time on the x-axis, and you have the different data sets with ERA being basically dense over the whole period. AROME is a local limited area model, so it's kind of not dense in a specific area. Then there's polar orbiting satellites and geostationary satellites that have a different pattern. And then there's DestinE, for example, also. And what we want to do is now we want to basically get rid of specific data points in here. And then we want to refill them with a machine learning tool. And by doing this, you basically learn a machine learning tool that can kind of really propagate information from one of those data sets into the other. So you can really kind of make satellite data out of reanalysis data. You can make observations out of, you can make a forecast model out of the analysis and stuff like this. You have very different ways of kind of basically generating information. And the third step that we want to do is we also want to scale up. So this is a plot where you see the complexity of different machine learning models for the LLM type models against time on the x-axis. And this is in degrees of freedom. So we have 1 trillion degrees of freedoms on the top, which we have reached by now in 2025. And at the moment we are here with 200 million degrees of freedoms for a state-of-the-art machine learning models that as we use it at DestinE. So we're kind of way off. So this is 2025 and 200 million degrees of freedoms. So it's way off, orders of magnitude smaller than the largest machine learning models in other domains. And that's, again, something we want to address with the weather generator, pushing all the way up to something like 100 billion degrees of freedoms in the mix. So the tool that we will get should be basically a very large machine learning tool that has a very large so-called data space. So it has kind of stored a lot of information intrinsically about the atmosphere and the land surface. And then we can use it for a lot of different application areas. So if you give it satellite observations, for example, and you ask it to generate reanalysis data, you have a data simulation tool. If you want to kind of, if you give it IFS initial conditions and you kind of want to get the situation of the atmosphere in the future, you have a forecast model and so on and so forth. So you will be able to use that tool in a lot of different kind of application areas. As I said before, you could even just give it a date, like, I don't know, 2030 or something like this, and it will give you a weather situation as it could be seen in that year, basically. And then the very important component as well of the weather generator after this tool has been built is also to kind of apply to a lot of different application areas. So within the project, we have 22 different application areas that go all the way from water to food security, health, biosphere, renewable energy, all sorts of weather type applications. And they're going to look into those different application areas and then apply the weather generator in this context. And this should also then build basically a machine learned digital twin for destination Earth. The caveat to some extent is that we're still exploring the space, right? So we're building a very large machine learning tool with a lot of data, basically. And we still have to figure out whether these models are in the end actually going to be much better than task-specific models. So it is true that we still have to figure out that we still have to show and prove the pudding, basically, that these models are actually better than a tool, for example, that is task-specific for a specific forecast situation. That's a very ambitious task, but I think we have a very kind of great consortium as well to address this task. So you have here are the partners, basically. You will see 6 meteorological services plus ESNWF. You will also see research institutes like Max Planck in Jena and CMCC in Italy. You have industry partners like Statkraft or Caio. So it's kind of a good mix of people, basically, in this kind of space of high-performance computing, machine learning, and weather and climate science, and then basically also generating the impact with industry partners. This is the last slide, just to kind of show you how you can potentially interact with the project. We have a web page. It's kind of like a preliminary version of the web page. There will be more information coming up over time. Basically, we're still very much early in the process. Yeah, we also have a LinkedIn presentation that is very well taken up by the community. So if you kind of want to be kept up to date of the projects, please follow us on LinkedIn. We also have started a mentor program for the new starters in the project that will basically get them if they want to sign up, they can get mentors that will help them in the project itself. And also, very importantly, it's an open source code development as well. So the code that we are developing right now is already open source on GitHub. And if you want to get involved, you can basically just go to the GitHub webpage and pick up tickets if you want and get engaged. So that's probably a very good way as well. And finally, on the longer term, I mean, we just started, so therefore we're still developing the tool in the first place. But later on, we will also have external hackathons where we invite the community kind of to apply the tools at the hackathons as well for their specific applications. And we also will have what we call services. So we will actually have open calls where we will ask other people to kind of write proposals to get help with their actually specific proposals using the weather generator as well. Thanks a lot.
Thank you very much, Peter. We have a question for you in the Q&A box, so please go click on the Q&A box and you can type the question directly. I think there is also an extra question for Martin in the chat, so not the Q&A box, but the chat that has not been addressed from Vitaly Sharmar. So if you can go both have a look at these questions while we take a very, very short interactive session with Roberta to ask some short questions to you. I will just share the questions shortly and then leave it to Roberta.
Thank you very much, Maria. Hello, everyone. So we've gotten to learn a little bit more about the projects, of course, but it's nice, I think, to also get to know our audience a little bit better. So if you want to once again join us on Slido and answer these questions. So the first question is, for what do you need climate and or weather data in your work? This is an open question, so feel free to answer with anything you like, and it's an open-ended question. Yeah, that's research, of course. We have a lot of researchers in the audience, so that's not surprising at all. Which kind of applications have you heard of? Yeah, financing climate tech solutions, yes. Climate adaptation, yeah, we've heard a lot about climate adaptation policy, so supporting policymakers with adaptation policies for cities and on a national and international level. Research-based solutions would help people in the long run, learning, insurance. Okay, this is great. And actually, this leads very well into the next question, if you want to move to the next one, Maria. And please keep them coming in. Yeah, so for what do you primarily use climate and or weather data in your work? So we've we've looked into the needs, but what actually do you use them for in your daily work? Just let's see if the needs match our expectations and our daily work. Okay, so research and modeling, of course. Once again, this reflects a little bit the audience that we have in the room here today. Risk assessment and impact forecasting. Also long-term planning and scenario analysis. Some people also said operational decision-making, so logistics, construction, agriculture. Not that many for educational reach, and so on. Okay, very interesting. So research and modeling mainly. That's the main answer. Thank you very much, everyone. And then the last question. Okay, so how important do you think is high resolution climate data for decision making? So we're speaking about 5 to 10 kilometer scale. And this is a star rating system. So we'll decide if it's on a scale from 1 to 5 stars, how important do you think it is? Okay, we seem to have a very polarized answer here, of course. And it's one of the reasons why we're here with these projects today. So it makes total sense that we all think they are incredibly, incredibly important. So yeah, to explore a little bit more about that and to explore sort of future, the value of these projects and potential for collaboration and synergies, I will now leave the floor back to Maria to introduce us to the panel session. Thank you very much, everyone, for participating in the interactive session.
Thank you, Roberta. We will also publish the results of these polls in the slides of this event. And now we are to the final, let's say, 30 minutes of the event. That's for the panel discussion. So I leave the floor to Jenny and the panelists to address final questions, and we can absorb also the Q&A part inside your panel because, as you've seen, we keep receiving the questions all the time. So thank you. The floor is yours, Jenny, and rest.
Okay, thanks a lot. Yes. Okay, so yeah, so we have 3 panelists here, and you have already met Peter and Martin representing WeatherGenerator and UrbanAIR. But then additionally, we have also Nikolai joining us representing TerraDT. So Nikolai, if you want to briefly introduce yourself.
Yeah, my name is Nikolai Koldunov. I work in Alfred Wegener Institute in Avi and doing high-resolution ocean and climate simulations. And in TerraDT, I'm leading Pillar 5 on cryosphere.
Okay, great. Okay, so we have a few questions to you, and let's start with the question that each of these 3 projects that we have heard today develop a bit different type of digital twin. But where do you see kind of strongest points in convergence or for example, collaboration in these approaches, methods, and outcomes of these 3 projects? And maybe, I don't know, Nikolai, would you want to start answering this?
Yeah, sure. Well, I think the obvious common ground for us, and especially with WeatherGenerator, is AI, because in TerraDT we have AI components, and we develop the emulators mostly of our components of our system, right? So, but I mean, we are not aiming to this foundational model, but we're aiming for more specific, specialized emulators. And this is obviously, like, I mean, the way to the possibility to compare approach that is taken in WeatherGenerator to the approach to the more specific emulators that Peter was mentioning, that it's not really, we are not really still sure that this big model will solve all the questions, or they solve all the questions better than the specific models. That's this one thing. And another thing that I think is very interesting, what we are doing in TerraDT, is the coupling interfaces. And I'm very kind of, I really think that a good coupling interface could be beneficial for all 3 projects and for DestinE as well. In particular, where we can couple not just like, I mean, we can of course couple the urban models, but like, I mean, coupling AI-based models with physics-based models is an interesting idea. People now try to explore this realm, but I think it's only in the beginning, and we in these projects, we can actually try to do something in this respect as well. So that would be my take.
Okay, great. Thanks a lot. Peter, would you want to continue from this?
Yeah, absolutely. So I think we have 3 projects here, and they were kind of coming out of 3 different proposals, independently written, basically. So it could have been all sorts of different combinations of projects in the end. And I'm actually very happy about like how we are distributed over the space by now. So I think we are actually very complementary with the 3 projects. And from the weather generator perspective, I mean, we're building a very large machine learning tool. So we need data and we need uptake. So we need impact and people using actually our tool in the end, because I mean, the ambition really is to have a community model in the end. And I think with the 2 projects, TerraDT and UrbanAIR, we have basically very good interlinks in this direction. So TerraDT is basically providing data for WeatherGenerator in the end, I guess. I mean, obviously not only for the WeatherGenerator, but it's going to be very useful data. In particular, because if you want to do machine learning in the future, you really need model data at the moment to train from. So that's one thing. And you also need very high quality data and very high resolution data. So I think like kilometer scale models in the decades is really exactly the data set that we would want to need and want to need for training as well. So that's perfect. And then we need the uptake as well. And Nikolai, you already mentioned like how you could potentially use the weather generator, and I totally agree. I mean, there's a lot to explore, like how a task-specific model is comparing against the weather generator and how much weather generator can help for specific tasks and stuff like this. So I think there's a lot to explore really. And for UrbanAIR in particular as well, that's also true, because I think one of the specialties of the weather generator should also be this kind of idea to go from global then to local, and to kind of, the ambition is to go up to 100 meters. I'm not quite sure we will get there very soon, but it's going to be very challenging. But if that's possible, then UrbanAIR, for example, would also be like a brilliant use case, I guess, to some extent, because you will also have lots of different data sets and different kind of resolutions, and then we could probably also kind of think about using weather generator in that context. I'm still have to learn a little bit more about the street level data and how much that could potentially also be used for weather generator. That's probably like a very, very, very ambitious part there. So I won't promise anything, but I think that's also something we should discuss. So I think in general, I think the 3 projects are fitting very well together, really.
Great, thanks. Before I give the floor to Martin to continue, I also say now that, of course, you can also comment on this. So, for example, if Nikolai, you would want to also comment on what Peter now said, that would be also fine. So we can make it more like a discussion and not so that I ask question and you one by one answer. But I will anyway now give a floor to Martin to also answer this question.
Yeah, so I agree with Nikolai and Peter. I think it is a very nice mix of projects that we have here. Well, obviously, you know, in terms of the weather system, I think all models and all digital twins require essentially quick responses, quick turnover times. So AI acceleration is absolutely necessary. So in terms of what we can provide as a consortium is that we've got, you know, we've got data at lots of different resolutions. And indeed, I agree with Peter to say that microscale is very challenging, because it's in the end, it's the details of the 3D surface that really matters. But of course, we'll be kind of developing digital twins for that within our framework, and in time we might be able to integrate it in the weather generator as well. I think in the end, the main thing that I think we need to be aiming for is to design something that is useful to an end user, and that kind of reduces the complexity of all the data we provide. And I think this is something that we're all aiming to do, to simplify the process and to remove a lot of the kind of technical details that you need to understand in order to get practical predictions.
Okay, great, thanks. If there is no somehow immediate reaction on this by Peter or Nikolai, I can move forward. And actually, the next question is kind of linked to what you just said, Martin. So I maybe let you answer this first. So this is that, what do you see as potential bottlenecks that can limit the adoption of these digital twins by their target users? So, and maybe you can also mention still who are actually the target users. So if you want to start with this, Martin, as you were referring kind of to that topic, just.
Sure. Yeah. A pleasure. Well, I think there's lots of bottlenecks. Sometimes they're very practical, right? Do people like the interface? And if they don't, they will not use it. So user friendliness is important. You know, your ability, particularly because our kind of targets are kind of urban planners who need to think about lots of things except resilience to heat, right? They need to think about mobility, they need to think about the finances, all these things. They need to think about garbage collection, maintenance, all these kind of things. So actually, we're just a small part of this. So it's our ability to simplify model outputs. And also, I would say, our ability to incorporate whatever we develop in their decision-making process. I think it would be a mistake to try to develop a model that does it all, right? So too much optimization. It's very important to kind of get the human in the loop, because it's in the end the humans that need to make the decisions, and you want to have a system that supports it, not a system that tells you what to do but doesn't have all the information.
Okay, great. Thanks a lot for that. Okay, Peter, would you want to comment this next?
Yeah, sure. I mean, with WeatherGenerator, I think the hope really is that this is a community tool, and this is kind of like by the end of the official project, we hope to have like a very large user base of people basically being able to apply the WeatherGenerator in their context applications. And I mean, in terms of the risk, it's kind of always the nature of thing of those project calls, basically, that they will end at some point. So there's always a question of sustainability. I don't think it's a big problem in that sense, like more problem than for other projects, for example. So I'm pretty sure that we will find follow-on funding for a tool like WeatherGenerator, and also that the Met service and so on and so forth will be able to sustain it in principle. However, I think that's really where Destination Earth should also come in as a kind of, so it would be, I think, a natural fit to some extent for a program like Destination Earth to then swallow something like this that is developed in the Horizon projects, for example. So it's not a risk, but rather like an opportunity. And I guess the question is more like, what is Destination Earth doing in 5 years from now? But in principle, I think there's actually like a very nice way of getting this merged into Destination Earth. And also for a tool like WeatherGenerator, I think the user base, for example, is also like a fantastic opportunity to actually get users that you may not have gotten in the first place. So if there's like a very large user base in the user platform of people who actually get involved in playing around with your system data of the digital twins and so on and so forth, I think this also increases like the impact of that a program like WeatherGenerator can generate, in particular as well, because I think it's also like very complementary to what the machine learning projects in Destination Earth. They're kind of more building an Earth system type model, basically. And the WeatherGenerator is kind of being a more flexible tool that can then integrate between, kind of mix between the different data sets, I think is very, very useful. So not too many risks, but I think challenges, obviously, I mean, all of those 3 projects are very ambitious, if we're honest, right? So we will have a lot of work to be done in the next years, but I think we are all on a very good track.
Great. It is good to hear this kind of optimistic view on things. So Nikolai.
Yeah, I mean, from our side, I think TerraDT is closest, let's say, to the, well, at least for the destination, for the core climate DT part. So we are developing something that's supposed to be used directly in the climate DT. We still have a part that is more close to user facing, that's has the same exactly the same challenges that Martin just listed. But for us, it's like, I mean, the solutions that we develop for digital twins themselves might not work well, or they would be too expensive, and that's might be the challenges for integration with climate DT, with Destination Earth, and consequently to the users as well. But I mean, we try to overcome it. We have to keep an eye on the things that the solutions that we developed, the improvements to the models are also computationally computationally not that expensive as like as that we will not be able to run them in ClimateDT, and we don't have to drift too much far away from the versions that I use in ClimateDT. But here is like more technical. I don't know if like how much in depth we have to go in this, but yeah. So TerraDT is like feeding more to the models themselves, to the digital twins themselves, and here the challenges are more on the technical side. And the user-facing part is similar to what Martin was talking about, that the interfaces has to be right, so it has to be kind of useful. Don't try to teach the people what to do, but provide the information and give them options, and just an info that they can work with, not the solutions themselves, maybe.
Okay, great. Thanks a lot. By the way, I will also mention, Martin, maybe you didn't notice, but in the Q&A box, there is still a more detailed technical question to you. So if you have time to
Okay.
answer.
Okay. Thanks.
Okay, great. So then, as the final question to the panelist, maybe Peter can start. Then this time I would have the following one. So what would you see as the most valuable feature or insight that your digital twin will bring that is currently missing from Destination Earth or some other tools that are available?
Yes, I mean, with WeatherGenerator, I would really hope that this provides a tool that someone who's kind of bringing some application data to the system. So let's say some energy provider is having some energy production data somewhere, or someone wants to look into specific flooding events over in a specific area of Europe and these kind of questions, or like all sorts of questions where people basically bring their own data, if you want, with them, but they want to kind of link them somehow into the bigger picture of the digital twins of Destination Earth, whether it's the extremes or the climate twin or something like this. And I would hope that WeatherGenerator would actually kind of help to be an easy tool that can be downloaded and used with kind of a lot of example applications as well, and this kind of different application areas, where people also like have code that they can just adjust to their own needs, but based on a very similar application in principle. And then without the need of going to like a very complex machine learning task where you train a very, very large model from very large data sets, because the digital twin data sets are very large. The hope would be that you can use a WeatherGenerator to kind of mitigate like a lot of this and basically just use that as a big tool, and then just train a very small tool to kind of do walk the final mile to your application, basically. And I don't think that's something that is fundamentally missing in Destination Earth that it is right now. I think Destination Earth already have a lot that is going to this direction, but I think it's just an additional tool that is basically covering the machine learning part there, and I think it's fitting very well. And yeah, let's see how far we get, I guess.
Okay, great. Thanks. What about Martin?
Yeah, from our perspective, it's really kind of the micro scale perspective. So the local impacts that interventions, planning decisions have on concurrent air quality, heat resilience, etc., but also future heat resilience, and also to provide planners kind of with kind of an idea of how to prepare for future things. For example, we've got this air quality directive coming in that by 2030 the emissions or the air quality in all of our European cities need to be improved. And one of the tools we're developing with Barcelona is kind of a tool that will able to say, okay, given a number of scenarios, what will it look like in 2030, and what do you need to bring your concentrations down further?
Great. Thank you, Nikolai.
Well, from my perspective, again, coming from the fact that TerraDT is mostly trying to improve in general, the simulation quality of the ClimateDT in our case, is the benefits for the user will be the better climate projections, right? So that's the information that you will be getting is going to be more rich, also with additional variables, and with more Earth system components included, you will be able to produce climate projections that are more robust and trustable. And that's also improved the data that we will be feeding to WeatherGenerator and to UrbanAIR. Right, so that's, I think, the biggest benefit. And better individual components, of course, right now the CIs, let's say, is great in ClimateDT, but not perfect. So we want to make it even better, and that means that the users who, for example, interested in the CIs will be getting a better information. So that's, I think, the main benefit for the users from TerraDT.
Okay, great. Thanks a lot, all of you. And now that was the last of the kind of official panel questions, but now I believe that there is still time for the audience to ask questions. I don't see, there's only this one question to Martin that was in the Q&A, which is a bit more kind of
I'm answering at the moment.
Yeah, I noticed that you are typing the answers, but I don't see at the moment other questions. Theo, I don't know, is there something that you would want to ask from the other panelists? Or everything is already clear? Or is there anything that you would be interested to learn more about one of the projects?
The answer is no, and from my side, but it's a good thing because we basically already had a lot of interactions between the three projects. So I think I actually know quite well what the other projects are like and about. So unfortunately, it's a no for an answer, but actually, I think it's a good thing.
So I've actually got one for the TerraDT, which is that presumably the climate digital twin already has, whatever land and sea ice parameterizations active at the moment, and aerosol things. So are they just kind of more complex, more complete models, or is it just kind of essentially externalizing those modules so that you can swap them out, or both?
Well, it's actually both, right? So the ClimateDT, of course, has already in CIs, and what they doesn't have a land ties, so that's a new component. And we know that kind of our models are far from perfect, and we also want to improve them. And I think right now, like with the components that we selected for TerraDT, there is a lot of rooms for improvements, and that's why I'm saying that we hope that we will have at the end of TerraDT much better representation of the climate system in the ClimateDT models. But also the fact that right now in some of the ClimateDT models, the components are tightly linked together, and like, I mean, again, going too technical maybe, but it's in one executable, something that we want to also work a little bit more in TerraDT and kind of disassemble them so that it allows you to, first of all, be more computationally effective, but also like seeing what happening in the AI world, and to allow to switch and swap the components, right? To like use, for example, physics-based model for the most part, but CIs is, for example, is AI-based. Maybe it's more effective. Maybe you can have higher resolution faster with the CIs, or with glacier models, which are very slow.
Or more kind of flexible model tool chain.
Yeah, so it's more like a Lego box, becoming a more Lego box instead of just a big monolith that it's very hard to disassemble. And that's also opened the possibilities for something like urban models as well, to be plugged in directly into the system, instead of maybe being kind of fed with the data only, and maybe also potentially in the very far future to also be interactive inside of the system. Because right now our mode of operation is that we provide the data as boundary condition for things like UrbanAIR models, and I mean, there is no feedback back to the climate models. I mean, that's also opens the possibility to do this kind of things potentially.
Okay, there is actually now a new question in the Q&A box that maybe actually perhaps even all of you could reflect on. So this is that how much confident is there now in the underlying climate models, but I believe this can be also answered like whatever models you are used in the digital twins, there is to produce information reliable for decision making. Who would want to start?
I mean, if it's about climate models, it's probably also
you can start, Nikolai,
more
but I was thinking that maybe Peter and Martin can also comment more generally on their model side. Yeah.
Yeah, well, I can start with the climate models, and for climate models, I mean, we see that for the high resolution coupled models, we achieved the quality that is better than the average CMIP6 model. So I think we can confidently say that we at the kind of better half of the quality of information is at least at the better half of the CMIP6 models, and the locality is unprecedented. So the amount of information that is kind of really close to the users, again, not as close to the users as UrbanAIR. I mean, 100-meter resolution scares me a bit, but I mean, we're still much better, much closer than the typical, let's say, 100-kilometer resolution CMIP model. It doesn't mean that we kind of replacing the information that CMIP provides. We are complementary to what to the activities in CMIP and in Cortex as well. But I think the quality right now, we are constantly evaluating them, and we are pretty happy with the quality. How confident we are, like, I mean, there are many sources of uncertainty. There is uncertainty of the models, there is uncertainty of scenarios, and so on and so forth. But right now, I think it's, if not the best, but one of the best sources of information that we can have at the present level of science development that we can have. So that would be my answer.
Okay, great. Thanks, Nikolai. Peter, would you want to comment on how confident you are considering the AI models that you are developing as part of the WeatherGenerator?
Yes, I mean, you can obviously criticize a lot with all the different physical models in principle, but the question is always like what can you actually answer? There are different questions in the climate perspective that are easier to answer than others, and also, I mean, these models are fundamentally the best tools we have. So I think that's like very much the stress as well. So I think they're very confident in a lot of the climate questions in principle. As Nikolai say, I think in particular for the local scale, I think these like kilometer scale global models are really also very much bring a lot of benefit into the mix. It also depends on how long you want to look into the future, whether decades or centuries and stuff like this. But from a machine learning perspective, you really need those data sets. I don't think, so I was just at a conference 2 weeks ago in the US that was basically about exactly this, like what can you do with machine learning models in the climate space? And I haven't seen a single talk or poster where they were basically just using machine learning without involving training data from those climate models into the mix. And they're really for the WeatherGenerator perspective, the kilometer scale is also very important because you don't want to just have any odd data. You want to have the best possible, and then you basically want to really push the quality, and that's what you do with those kilometer scale models, like for example in the climate twin. So I'm not saying you can answer all the climate questions confidently with those physical models. That would be too much, but I think these are the best tools we have, and they also have a very good track record. If you look into the predictions that we had, like for today's climate from 20 years ago, for example, they do get things right. So I think we can be confident that we can learn something useful from there.
Thank you. Then Martin, would you want to comment this on kind of UrbanAIR perspective, that how much you have confidence in the models that you are developing there?
Well, so as Peter says, they're the best we have, so we should use them. And then there's also different scenarios, right? So in terms of practical aspects, that is kind of an important part of the uncertainty, right? The biggest uncertainty is what we as a species are going to do in the next 50 years. Well, the answer seems to be a little bit, probably not enough, but hopefully we'll get a bit more active with this. But that needs to just be built in. That needs to be built into the predictions, and you know, one of the things we're planning to do is to give for the different scenarios, we can project different futures, and you know, it's up to decision makers to kind of to use that information, right? So we can just provide the information, and then it's up to decision makers to kind of decide how resilient they want to make their cities.
Okay, great. Thank you a lot. Thanks a lot, all the panelists. And now I will give the floor to TrustIT colleagues to close their webinar.
Yes, thank you, Jenny. Thank you, everyone. We've reached the end of this event. So just a few words to say, this was the, let's say, initial joint event, but we plan to basically do others. As you see, the connection is already, you know, quite strong between the three projects. So we'll follow all the project channels, the three project channels, to be updated on when we will have other joint initiatives or, you know, project specific initiatives. Thank you again, and everything will be posted on our channels and on our website in the next few days. Have a good day, everyone.
Thank you.
Bye-bye.
Have a good
Bye-bye.
day.